So this is the next lesson for Module 4, Part 1. All right, and we're talking about transformations of periodic functions. Okay, so periodic functions are trigonometric functions. So there's two main types you're going to see as we go through this. There is either sine of x or cosine of x. These are the two types of functions you'll generally see for periodic functions. And what happens with these functions, they just keep repeating over and over again, the same kind of thing. All right, but the transformations that we're going to see are basically the same idea that we've used for all the other types of transformations and all the other equations we've looked at. All right, now there are some slight differences, but not really anything big. All right, we're going to point out what those differences are and show you how they affect everything. All right, so the first thing we have, you can see that there are different things that are going on with the equation. Okay, so let's highlight those. Let's do red. Okay, so the first thing here, A, if something is in front of the function that's worked like a vertical stretch or compression. Okay, if we have B, this is going to be your horizontal stretch or compression. You have C, that is going to be your horizontal either left or right movement of the graph. Okay, again, it's going to be the opposite of the sign. Okay, so if it's negative, it goes to the right. If it's positive, it goes to the left. And then finally, D is going to be your vertical movement. So if it's positive, it goes up. If it's negative, it goes down. So we're going to show you how all those things work and what they would look like in the equations. Okay, so the first one we look at is the A value, if the A value is something other than 1. Okay, now there's something that is a little bit different on this one because your A value here, you notice this time it's going to be an absolute value. Okay, the reason why the A value is going to be an absolute value is because the A value is also the same thing as your amplitude. Okay, we looked at this on the last lesson, that your amplitude is from the midline to the top of the periodic function or the midline to the bottom. That is your amplitude. Well, your amplitude in a periodic function is always going to be a positive number. Okay, and now it can't have a negative sign in front of it, but when you write down an amplitude, it's not -3, it would be like +3. Okay, and the negative would mean that it is been flipped over the x-axis. It's been reflection. Okay, so that's why that's an absolute value, because no matter what A is always got to be a positive number to be the amplitude. Okay, now if A is going to be greater than 1, you're going to have a vertical stretch. Okay, so let's look at an example of what that would look like. So f of x is equal to, and I was just mentioning 3 sine of x. And there we go. That is going to be a vertical stretch of 3. And in this case, this is also, that 3 is also the amplitude. Okay. All right, next, we're going to have a vertical compression. Again, we're looking at the absolute value. Okay, because again, the amplitudes of periodic functions are always going to be positive numbers. Okay, now they can have a negative sign in front of it, but that doesn't mean the amplitude is negative. All right. So if we're doing a vertical compression, notice it is between 0 and 1, so it's got to be a fraction or a decimal. Okay, I'm going to write both just to show you. We have f of x is equal to 1/2 times sine of x. All right, we could do the same thing as a decimal. Equals 0.5 times the sine of x. Okay. And then lastly, if A itself is less than 0, that's when you get reflection. All right. So if you have a reflection, and use the 3 again, you would have -3 times the sine of x. Now in this case, what you would do, if you were asked for the amplitude is the absolute value of A. If A is -3, then the amplitude would be +3, okay? The amplitude is always a positive number. It can have a negative in front of it, but that just means reflection. It doesn't mean the amplitude is negative, okay? So the vertical compression or a stretch would be a number in front of the sine or cosine term, all right? And then a negative in front of that number would give you a reflection over the x-axis. All right, now we have horizontal compressions, the B value, okay? Again, it's an absolute value here because it's going to be a positive number. If it was a negative, then you have something else that's going on, so it would be a reflection. We'll get to that in a moment. So horizontal compression. So if you have a number in front of the x term inside the function. So let's look at what that would look like. So you have f of x. We're going to look at sine again. So we're going to have the sine of 3 times x. Okay, so this would be a horizontal compression. All right, if the number is a fraction on the x term, or sorry, the b term, all right, then it's going to be a stretch for horizontal. So f of x is equal to the sine, and we're going to have x over 3. Okay, this would be a horizontal stretch. It's going to make the period go longer, and a horizontal compression would make the period go shorter. Okay. All right, and then if you have a reflection over across the x or the y-axis, your b value will be negative. So we have f of x is equal to the sine of negative 3 times x. Okay, so that would have a horizontal compression, and it would reflect over the y-axis. Okay, so it's two different things going on there. All right, next, horizontal shifts. Okay, if c value is going to be bigger than 0, it's going to be a shift to the right, because in the formula it's a negative. I had to think about that for a second. So how we would see this, so we have f of x is equal to the sine of x, and if we're going to the right, it's going to be minus, let's say, 3. Okay, so it's going to go to the right by 3. If c is smaller than 0, that means it's going to be a negative number. And if you put a negative number into the formula the way it says, since the formula has a negative sign in it, then two negatives give you a positive. So f of x is equal to the sine of x, sine of x plus 3 would go to the left by 3 units. And finally, we have the d value, which is a vertical shift either up or down based on if it's positive or negative. So we have f of x is equal to the sine of x plus 3. Notice it's not in parentheses, so it's going to be a vertical shift. And then we have f of x equals the sine of x minus 3. Again, it's not in parentheses with the x value, so it's going to be going down by 3. Okay, so let's look at some examples in equations and then talk about their transformations. All right, so here we go. We have two separate transformations in the first one. Okay, we have the 4. So this is a vertical stretch. Oops, spelled it wrong. By 4. And we have your whole equations going up by 3. Okay, the 4 is also just so you can see this in the future. The amplitude of the equation is going to be 4. Okay, because that number in front of that sine function. Okay, that's not a transformation, but it is pieces of the information that we've already looked at, and that's where you know where it is. All right, number 2, we have a reflection over x-axis. That's what this is. This is the first one right here. All right, and then we have a horizontal shift to the right by 4. Okay, number 3. We have a horizontal compression by 2, and we have going down by 3. All right, number 4. We have 4 different things going on. So let's take the first one. We have a vertical compression by 0.5. We have a reflection. Let's make this bigger. We have a reflection over the x-axis because it is negative. Again, your amplitude for this particular equation would be 0.5, not negative 0.5, but 0.5 because amplitudes are always positive. Okay, you always talk about amplitudes as being positive. All right, then we have a horizontal shift to the left by 1. We have vertical shift down by 2. Chair is squeaky here. All right, next we have, again, 4 different things going on. We have a vertical stretch by 3. We have a reflection over the x-axis. We have going to the left by 2, and we have going down by 1. Again, for this particular problem in question number 5, your amplitude would be 3, because it would be positive as an amplitude. All right. Next one, number 6, we have a reflection over the x-axis. We have a horizontal stretch by 1/4, and we're going up by 3. Okay, only 3 different things going on in this one. All right. We got 2 more to go for this particular chart here, or table. All right, again, we have 4 things going on. We have a vertical stretch. Okay, although this is as a decimal, because it's bigger than 1, it is a stretch by 2.5. All right, because it's negative, it's going to be a reflection over the x-axis. All right, it's going to go to the left by 90. It's going to go up by 1. Okay, and lastly for this table, we have number 8. Again, we got 4 things going on. We have a vertical compression by 1/2. We have reflection over the x-axis because it's negative. We have a horizontal shift to the left by 60 and a vertical shift up by 7. Okay, so those are the different transformations you have for these equations. Okay. Now in this particular, for 13 through 15 on this, I don't know why it's 13 through 15 because it stops at 8 for the previous one, but that's okay. All you want to do is you're going to list out the transformation, what's going on with it, and then put in the cosine function in for m. That's really, or the sine function for number 15. So let's look at these transformations and then write the equation down. So for the transformations, it is a vertical compression by 0.5. And there is a horizontal shift to the left by 3. So if you were to write this out, you'd have 0.5 times the cosine of x plus 3. And that would be your transformation. Okay, let's put what's an equation be? An equation for t of x. So we're going to write t of x. You know what? Hold on. Let's rewrite this. I don't like that. That's ugly. I jammed it in there too much. Okay, so we got t of x is equal to 0.5 times the cosine of x plus 3. There we go. That's a little bit better. Okay, next, for 14, our transformations are, we have a reflection over the x-axis. We have a horizontal compression by 4. And we're going down by 1. There you go. So to write this out, we'd have t of x equals negative. We're doing cosine of 4x and then minus 1. Okay, so that's all you have to do is put the cosine in for the m value. All right, and lastly, we have three different things going on in number 15. We have a vertical stretch by 2. We have a reflection. And this time it's over the y-axis because it is inside the parentheses. And then we have a vertical shift by 5 going up. So I had to write this on. Now this is going to be a sine function, so we're going to have t of x is equal to 2 times the sine of negative x plus 5. And there we go. That is it. See ya tomorrow.